Hi everyone, welcome to my new tutorial. In this one I'll be showing you how to create something like this. So basically a fluid simulation inside of an animated object. So let's go ahead and start by creating our animated geometry, which in this case will be the font. So let's drop down this font and let's write something. Animate, for example, let's write Houdini. Let's write the age, go to some maybe 20 frames later. Oh, you. Okay. Let's hope we spelled it right. Oh. Okay, looks like so. So let's extrude it. So poly extrude like 0.1 should be enough. And we need to close the backside, so output black. Otherwise our collision will not work properly. And I will scale it up at least 2 or 3 times. That's because it will give us better details with our fluid simulation. Let's choose our null and write out collision. Okay, we are done with our collision. Let's name it collision. And now let's go and make our flip simulation, starting by the source. So let's call it flip sim. We can make it blue just for fun. So I will start from a simple box and I will ghost it so we can see our letter H. We'll make it narrow, like real narrow. 0.02 is fine. And I will try to make it narrow so we can fit inside of the letter H. Maybe even more narrow, something like this. And I will translate it inside of our letter H to the center. Nope. I will copy our transform and move the second one to the other side. Okay. Just some small tweaks. And now we need our flip source. At this point we can hide our letter H. So let's drop down the voxel size like 0.2, maybe 0.1. The same for other one. And let's make it colorful. So just to have something visually interesting, let's make this one red and the other one like blue. And at the end we merge them together and we add another null object to keep it organized and out fluid source. That's it, we have our source, and now let's create our simulation itself by dropping down on dot network. And for our flip simulation we'll need our pyro solver, not the pyro solver, flip solver. Flip solver, flip object, and our source, which will be source volume. Okay, so in our volume source we need to point to our source. We can point to this null from this subpath, or we can just choose first context geometry because we have already connected into first point. And let's change it from source smoke to source flip. Okay, now let's go to flip object. We don't need this initial list of path, so let's delete it. Let's go to guides, particles, and instead of sprites, let's visualize particles. Okay, and the color let's to none. When we choose none, it will display our source colors which we want. So one last thing here, we need to copy this particle separation to have the same parameter in our flip source. So in the particles tab, let's paste it here. The same for the second source. Okay. And I will make the particle separation much smaller, like 0.2, maybe 0.15. And our container is huge, so let's make it much smaller. And on this side, I will make it like real narrow. So our particles will not go out from this boundary. Let's choose a gravity force. Let's play and see what happens. This happens, just particles falling down. We need them to emit only at the first frame, so let's write $ff smaller than 2, so it will emit until the second frame, like this. Now let's go into flip object and close boundaries. Now our container will become collider. Yeah, so now we have our mixing fluid, and now we can take care of our collision. So let's select our collision, static object, go back to our simulation, and we have these nodes created for us. Okay, let's don't display our geometry, and instead let's visualize the guide. Let's give it like more fine details, 0.1. And we need to invert sign because our fluid simulation will happen inside of our shapes, so like this. Okay, let's play and see what happens. Yeah, nothing interesting. In my example, I didn't use gravity, and instead I use like pop force, just a noise, like 2, something like this. Yeah, it's already getting there. So to have our animated geometry, we'll need to check use deforming geometry, and let's play. This is our O. Also our boundary object is quite small, so let's make our boundary box a bit higher and a bit bigger on the size. Play again. One thing we can do to fill up our letters more is to use gas particle separate. Yeah, this one. And let's add a merge node here because we will need to use few forces. What this node will do, it will keep particles away from each other uniformly, so therefore they will fill up more space. Yeah, now it's much better. And later we will delete these outside points. So default number was 1, so below 1 it will keep particles away from each other, and above 1 the opposite, it will keep the particles together. Like if you try like 0.5, let's see what will happen. It squeezes them together into these droplets. 0.1 works the best for us. Okay, so I think we can cache at this point and take care of these outside particles. So let's drop down a dop import, and drag our dop network there, change it to face geometry, and inside of this object mask we'll need to write the name of our flip object. So I will just copy the name and paste it here. Drop down a file cache and just cache. Okay, so the caching is done. So let's check how it looks. It looks fine for now. We'll tweak some settings later. For now, let's focus on deleting these outside points. So we will group the points by our collision. So let's choose a group node, group type to points, and we need to object merge our collision. Let's go to our collision and this null which we made. So let's copy it, which will copy the path. So, and let's paste here, and we have our collision here. So we'll need to connect to the second input of the group and change the group type to bounding region and points. So, and yeah, we have our selection, and we will blast the outside points just by adding a blast node and choosing our group and invert. Yeah. Also, one issue that I have with this setup is when use deforming geometry is enabled, the particles behave a bit weird. But if we uncheck it, it will not take account the animated geometry. So what I did in my previous example, which I showed you, I animated this parameter so it is unchecked all the time and checked only when it's about to change the letter. So if you find a better way, let me know. That's what I will do now. So basically this parameter, the keyframe of this parameter should match when the text is changing. So let's see. Okay, so first it change at frame 56, then 79 and 106. So let's do it. Let's go here, disable the animation, the simulation, and let's animate the collision. So keyframe here, enable here when letter is changing, and go a frame later and disable it. So like this. Let's see how it looks. Like, look, when this using deforming geometry is not enabled, particles flow more easily inside our collider. That's why I think it's a good idea to animate this parameter. So now I will do the same for each keyframe. Maybe I will speed up the video so you don't have to watch it. Okay, so I did all the keyframes. As I said earlier, it should be checked when the letter is changing. I will use a flipbook. Yeah, it looks much better. This keyframe part is more work to do manually, but the result looks much better. So I will cache our simulation again because we updated our simulation, and basically that's it. In this chapter we will do the rendering. So let's go to our flip simulation. Here where we left off, I will add a null to stay more organized. Call it out particle rendering. I will be using Redshift as a render engine, so I will make a room for our render view by going here and choosing split bottom, top bottom, and from here I will add the Redshift render view. Okay. We should start by going to our flip sim, into Redshift object tag, particles, and select render object as particles. Let's see what we get. And we get lots of big white blobby particles. We can start from making our colors and our materials. So I will go to the material tab, create Redshift material builder, this one. I will call it particles. This is our output. We'll need Redshift material connected to the surface. And to get our colors from our particles, we'll need color data node, this one. Connect to our diffuse, and in the attribute name write CD. Let's start our APR. Okay, we need to apply our material, so flip sim, render, material, particles, update it, and here we have our colors. Okay, so the next thing we'll do, let's define our particle scale. So for the pscale, I will use point warp. This is my favorite way to make the pscale, and I learned it from some Endagma tutorial. So I will start by a noise, which will be NLS noise in our case. Click position to position. For now we can connect it to our color just to visualize here. We don't need this. And to get better values with our noise, we'll need to remap fit range to remap our values from minus 0.5 to 0.5. And now I will create the ramp, and after ramp another fit range node, and this fit range will control our minimum and maximum particle scale. So let's promote this destination min and destination max, and the ramp needs to be spline ramp. Okay, now let's make a bind export, and let's write pscale. Instead of color, I will connect it to our pscale. Let's go back. This is our spline. Just to visualize our pscale, I will quickly create a copy to points node. Connect the sphere. We'll not use it for rendering, but just to visualize the particle scale. Okay, so it's too big. We can go like 0.005 and 0.00 maybe 9. Let's zoom in. One more thing that we can promote is the frequency of our noise. Let's promote it, go back, and let's add more frequency to our noise. Something like this seems fine. And let's crash our values so we have more noticeable difference. Like these piles of big and small, something like this. I think bigs are too big. Maybe it's fine, but let's make it like 0.08. I just noticed that these two things looks like hearts, so it's kind of cute. And let's continue. So I will delete our copy points because we just need it for visualization, and let's call our attribute verb pscale, and let's start our IPR. Looks fine for now. And let's start with our lighting. I will go from like left side, maybe a bit top, something like this, and create a redshift light. I will call it right, and I will make it bigger, something like this. I will create another one from top. It will give us better highlights, something like this. So another redshift light. Let's go back to our camera. I will disable our right light so we can only see our top one. I will call it top. We'll try to make it bigger to see if it's good. Maybe not too big, something like 1.5. Let's check it together. Enable our right light. Yeah, it's good, not bad. I will add one more light from the back, and we'll use it as our volumetric light. So I will go more or less back and top, something like this. To the center, create another light. Go back to our camera. Call it back. What's up with my keyboard? Back. Okay, so I will go to our output in the Redshift tab, volumetrics, enable, go back to our backlight. I will scroll down to find the volume tab, and I will write something like 0.1. 0.05. I will lock my camera and see, maybe it's too high. I will bring it a bit lower. Yeah, this looks better. And I will use a bit bluish light, just looks cooler. Yeah. Okay, I think the contribution can be even smaller, like 0.02, maybe 3. Yeah, something like this. I will disable our top and right lights to see what effect has the backlight. It will create these nice highlights for us. I will enable our right light and top light. I think our right one is a bit too bright, so like -1. So now I have enabled all the lights. Also I will go to IPR and enable IPR live SOP updates. So whenever we change the frame, it will update in the IPR. Well, looks not bad. Still, I think our pscale is too big, so I will dial it down. Go to our pscale, and where is our pscale? Like 0.05 and 2. Maybe something like this is better. Can I make this bigger? Okay. And yeah, I think it's starting to look better. And it's even better when it's already mixed like this. And one more thing we can do is to add motion blur. So I will go to our flip simulation, sampling, add velocity blur, go to our output, Redshift, motion blur, and enable the motion blur. Let's update it and we will see this. We have a motion blur. Is it too crazy? Yeah, looks like it's too crazy. If it's too crazy, you can reduce the frame duration, like, and update your IPR 0.2. Yeah, something like this is better. Okay, so basically that's it. I will render this sequence right now and come back when the rendering is done. Cool, so there we have the result. Looks fine so far. I will just do one final note here. This like groups is basically the noise itself. If you want to make it move with the particles itself, you will need to use the rest fields instead. I will quickly show you how to do it. Basically, just before your DOP network, create a rest field, rest position. After it, you will need to cache your simulation because we updated, it's a new attribute. And later, after the caching, instead of this position, you will do a bind node, and here you will write rest. And the rest is a vector value, vector, and just connect it to the, and connect it to the position of the noise. And I think it will give more organic look. So there you have it. Please like the video if you find it useful. I will also include a project file so you can download and play around. And that's it. Thanks for watching and see you next time.